In this video, I'm going to draw a random sample from this dataset and then fit a regression model using just x to predict y, and then fit a regression model using both x and z to predict y. So to draw the random sample, I'm going to say data select cases, random sample of cases, sample exactly 5 from the first 1,000. And delete the unselected cases, and that will leave me with the 5 cases that were randomly selected from the original data set of 1,000 cases. To fit the regressions, I'm going to say analyze regression linear. The dependent variable is going to be y. In the first model, x is going to be the independent variable. And then to fit a second model, I'm going to say next, and I'll have x and also z as the dependent variables in the second model. And to compare the models, I'm going to say statistics, and then check the r-squared change box. And say continue, and say OK. And then SPSS will give us all the following output. And this output will include a model summary table. This includes the r's and the r-squared, adjusted r-squared, and also a test for the significance of the variables that are in each model relative to a simpler model for both models. So to figure out if adding z to a model that already includes x and a constant helps you explain more variation, you can use this significance and compare it to an alpha level. Or you could also use this f statistic with these degree of freedom numerator and these degrees of freedom in the denominator. You'll also have an ANOVA table that has the sums of squares regression, sums of squares residual for the first model, which includes only x, and also for the second model, which includes x and z. And you'll also get the coefficients for each term in each model. So in model 1, there was only the constant and x1, and you have the b coefficients for those. And in model 2, there was the constant x1 and z, and you have the coefficients for each of those.